There's this unseen sorter in your life. It's a technology that's constantly humming away in the background, sorting, identifying, predicting. And most of the time, you probably don't even notice it's there. Have you ever really thought about that little moment of magic? You just pick up your phone, glance at it, and boom, it unlocks. How in the world does it know that's you and not your brother or your best friend?
Or how about this one, your email inbox? How does it manage to wade through that endless stream of messages and just perfectly pluck out all the junk? All those crazy discount offers and weird solicitations get filed away, keeping your main inbox actually usable.
Well, the answer to both of those questions, and honestly, a whole lot more, is this incredibly powerful field called pattern recognition. It's really the invisible engine driving so much of the tech we use every single day.
Okay, so let's break it down. What exactly is pattern recognition? Let's get right to the heart of it.
At its core, it's really all about teaching a computer to find regularities, patterns, in massive amounts of data. Once it learns what those patterns look like, it can then take action, like sorting new information into the right categories. You can almost think of it as training a machine to be a data detective.
Now, this is a really, really important distinction to make. On one side, you have simple pattern matching. Just think of hitting Control F to find a specific word. It's totally rigid. If you search for cat, it's not going to find cats. But pattern recognition, that is a whole different ballgame. It's way smarter because it thinks in terms of probabilities. It can look at 100 photos of you smiling, frowning, or wearing sunglasses and still know it's you because it's looking for the most likely match, not a perfect pixel-for-pixel copy.
But how does a machine even learn to see these patterns to begin with? It's not magic. It's all about the training process.
So there are two main ways we teach these machines. On the left here, we've got supervised learning. This is kind of like you're a teacher using flashcards. You show the machine tons of data that we've already labeled. This is a dog. This is a cat. It learns by example from a human teacher. But then on the right, you have unsupervised learning. This is completely different. It's more like you just dump a giant mixed-up pile of Legos on the floor and tell the machine, okay, you figure it out. There are no labels. It has to find the hidden patterns all on its own.
And here's what you get from those two methods. That flashcard approach, the supervised one, leads to what we call classification. The machine can take a new piece of data and put it into a box we've already defined, like spam or not spam. And that Lego sorting method, well, that leads to clustering. That's where the machine creates its own groups based on the similarities it discovers, without any help from us. So whether it's classifying things into boxes or clustering them into groups, what is the machine actually looking at in the data? What are the clues it's using to make these decisions?
Well, it all comes down to an item's features. These are just its measurable characteristics. A feature could be something categorical, like your blood type is A, B, or O. Or it might be ordinal, meaning it has a clear order, like t-shirt sizes. It could be a simple number, an integer, like counting the words in an email, or it could be a very precise, real-valued number, like a blood pressure reading. These features are basically the raw ingredients the algorithm uses to start seeing the patterns.
All right, that's enough of the theory. Let's talk about where this stuff actually shows up in the real world. Because I promise you, it's making a huge impact in some really amazing, maybe even surprising places. And we have to start with the most obvious one, right? Facial recognition. Every single time you unlock your phone with a glance or an app automatically suggests tagging a friend in a photo, yep, that's pattern recognition in action, analyzing all the unique features of your face to make that most likely match. But it goes so much further than that. In medicine, it's helping doctors spot diseases on medical scans. In our cars, it's the brain behind advanced driver assistance. It's what lets your phone understand what you're saying, and it's how the Postal Service can somehow decipher messy handwriting on an envelope. And of course, it's that trusty gatekeeper, our spam filter, protecting our inboxes 24/7. So as we wrap this up, let's circle back one last time to the most important idea, the one thing that really defines what this technology is all about. And this quote, it nails it. The goal isn't perfection. It's about providing a reasonable answer for whatever you throw at it and performing that most likely match. It's not about finding a flawless 100% identical copy. At the end of the day, that's the whole game. Pattern recognition is about calculating probabilities, not finding perfect duplicates. It's a powerful tool that allows machines to find order and make sense of our incredibly messy, complicated, and ever-changing world.
And that leaves us with a pretty fascinating thought, doesn't it?
These systems are designed to see regularities in our data, in our behaviors, even in our biology. So as they get better and better at seeing these patterns, what hidden truths are they going to teach us about the world, and maybe even about ourselves?